Hello everyone. Welcome once again in our very journey of examining the science of measuring triangles. We have come pretty far in this journey. Today what we have to explore is a very curious question. The question is asking for conversion of one trigonometric ratio into the other. What do I mean by that? Well, that is going to be clear to you from the very context, because today we have to study interconversion of trigonometric ratios. What do I mean by this? Well, suppose you have your sine with you. Can you express sine in terms of cos? Can you write tan in terms of cot? Can you convert cosec in terms of sec? All such combinations will be encountered under this topic, and you, after studying this particular topic, will be able to convert any trigonometric ratio into any other trigonometric ratio. So let's get started with the very first conversion. The very first conversion deals with teaching you to convert or to express a trigonometric ratio in terms of sine. That is what is our very first type of conversion. Over here, we will be able to learn to convert any trigonometric ratio into sine, or in other words I should say, we will be able to express every trigonometric ratio in terms of sine. Let's start with that journey. But before that, you should be very much aware about the behavior of sine. We all know that sine of any angle is what? Well, you need to pick up the adjacent, not the adjacent but the opposite side of this angle theta and take its ratio with the hypotenuse, and therefore you get opposite upon the hypotenuse. Because the opposite side is also called the perpendicular, and the hypotenuse remains the same, you get that sine theta can also be written as perpendicular upon the hypotenuse, which in short I express as P upon H. Now that we are aware about the meaning of sine theta, which is the ratio of perpendicular with the hypotenuse, the second thought is, what are these opposite sides and the hypotenuse? Well, the triangle of reference of theta needs to come into picture to give us information about all these sides, and therefore we need to have this representation of theta with us. Suppose your angle theta happens to be this. Then we need to make the triangle of reference of theta to pick up the opposite side lying opposite to theta in the triangle of reference, and to pick up the hypotenuse as well, and then get the ratio and then get the sine theta. But here I am going to do a certain smart manipulation. In order to express every trigonometric ratio in terms of sine, I am doing that. What is it? Over here, I know sine theta is P by H. I don't want my sine theta to come as a fractional value. In fact, I want it to come as an integral value with denominator to be 1. So let's do that. You need to make the triangle of reference with the length OP to be 1. The moment you take your h to be 1, you get just p upon 1 in picture. Just take your p, which is acting for the perpendicular which you drop on the x-axis to complete your triangle of reference. Just take the length of this perpendicular to be equal to s. And what you have is, you have in the triangle of reference OMP, this is the triangle of reference of the angle theta. So in the triangle of reference OMP of the angle theta, we have that your OP, which is acting as the hypotenuse of this triangle, largest side is equal to 1. And your perpendicular PM, I have taken that to be S. Once I have taken this, what happens to my OM? Well, we all know that hypotenuse square is equal to base square plus perpendicular square, right? And therefore, I'm just going to write that as OP square is equal to OM square, the base square, plus PM square. Just substitute the values now. Your OP is 1. Your OM is equal to, we don't know. And your PM happens to stand as S. And now you have the value of OM. Your OM happens to be under root 1 minus S square, where your S is nothing but the length of the perpendicular. Why am I not writing minus over here and I have taken over here the sign to be plus? Because OM is the length of a side. How can it be negative? Of course it needs to be positive, and that is why through this calculation you have that OM is equal to 1 minus S square. And now in this way you have all the three sides of the triangle of reference of the angle theta with you. And now we are in a position to find out any trigonometric ratio in terms of sine you wish to. Let's start with sine theta itself. Well, sine theta was perpendicular upon the hypotenuse. The perpendicular has S as the length, and your hypotenuse we took to be 1. This was done deliberately to get sine theta as S. Now we begin expressing cos theta in terms of sine. How do we do that? What do you mean by cos theta? Cos theta is nothing but the ratio of the adjacent side with the hypotenuse. The adjacent side is OM, the hypotenuse is OP. So you get cos theta as OM upon OP. But your OM has length 1 minus S square under root. So you get under root 1 minus S square upon OP has length 1. Thereby you get that your cos theta is equal to under root 1 minus sine square theta. Right? Because S is nothing but sine. So S square is nothing but sine square. And thus you have expressed cos in terms of sine. Let's move to tan. Tan theta is nothing but sine theta upon cos theta. Now sine theta is your S and cos theta is under root 1 minus S square, and that is why your tan theta happens to be sine theta upon under root 1 minus sine square theta. Just observe, the entire tan ratio is expressed in terms of sine only. Isn't this magical? Well, you would be curious as to what or how will we convert cot or sec or cosec in terms of sine. That's something very simple. Why? Because sec is nothing but the reciprocal of cos, and that is why sec of theta will be 1 upon cos theta, which is 1 upon under root 1 minus sine square theta. Again, sec is expressed in terms of sine. If you move to cot, cot theta is nothing but 1 upon tan, reciprocal of tan. So 1 upon this expression will just reciprocate this expression, and you will have under root 1 minus sine square theta upon sine theta as your cot theta. And that is going to complete your conversion of every trigonometric ratio in terms of sine. Important thing is not to be happy about the conclusion. Important thing is to see how have we reached to this conclusion. I did a very smart manipulation, which is what we will be doing for every other trigonometric ratio as well. What did I do? Just because I knew that my sine theta was p upon h, I ignored that I do not want this to come as a fractional value. I want it to come as an integral whole value, and that is why I made the denominator to be 1. That is the sole aim, the sole strategy. To make the denominator 1, over here the hypotenuse is sitting as the denominator, so we made hypotenuse to be 1. Just to get a single easy variable to work with, we took the numerator left out, which is your perpendicular, to be of length s, and then got every other trigonometric ratio in terms of s, which is nothing but my sine theta. The same strategy you can apply to convert every trigonometric ratio in terms of cos or tan or sec or cosec and cot. We'll see how that is done. Till now, just note this down and be prepared for that section. Do not forget the strategy which was used to obtain the trigonometric ratios in terms of sine ratio, because that is what is going to be followed throughout the conversion process. We obtained these as the values of cos and tan in terms of sine. And I told you that because sec, cosec and cot are nothing but the reciprocals of cos, sine and tan, it is very easy to obtain the reciprocal ratios in terms of sine just by using all these. What will be my cosec theta? Cosec theta is nothing but 1 upon sine theta. This is my expression of cosec theta in terms of sine theta. When I talk about sec theta, this is 1 upon cos theta, which is 1 upon under root 1 minus sine square theta. And this completes my expression of sec in terms of sine. When I talk about cot theta, which is nothing but 1 upon tan, you obtain the reciprocal of this expression. Just take the reciprocal and you get under root 1 minus sine squared theta whole upon sine theta. And this completes your conversion of every trigonometric ratio in terms of sine. Why don't we try to do something new? That is, let us take our very next venture to be learning to express every trigonometric ratio in terms of cot. Let's do that. Over here, we will be obtaining, after learning the entire process, as to how do we express every trigonometric ratio in terms of cot. Let's begin with that. For that again, what you require is the meaning of the cotangent function or the cotangent ratio. Well, cot of theta is nothing but adjacent upon the opposite. Right? Because cot theta is equal to the adjacent side of the angle theta in the triangle of reference of theta divided by the opposite side of the angle theta in the triangle of reference of the angle theta. To get the picture very clear, we need to have our triangle of reference in picture so that we can decide what is the opposite and which one is the adjacent side. So let us take this to be our suitable angle theta. And now we need to obtain the triangle of reference of this angle by choosing a point on the terminal ray of this angle and dropping a perpendicular from there on the x-axis. We have already learnt that irrespective of what point do you choose on the terminal ray to obtain your triangle of reference, the trigonometric ratio always comes out to be the same. The point which you choose on the terminal ray to complete the triangle of reference does not affect the value of the trigonometric ratio. That means I can choose my point P on the terminal ray as per my suitability. So what am I going to do over here to get all the trigonometric ratios in terms of cot? Well, because the adjacent side is also called the base and the opposite side is also called the perpendicular, I get my ratio of base with the perpendicular to be equal to cot theta. This I just write it as B upon P. Again, use the same strategy. I don't want my cot function to come as a fractional value. So what do? I make my perpendicular, which is the denominator, to be equal to 1. What do? We need to understand that the base upon perpendicular, which is happening to be B upon P. This is what happened. We had the base at the numerator, the perpendicular at the denominator, which we just in short form wrote as B upon P. And as I told you that the denominator will have to be equal to 1 to not let cot theta come out as a fractional value. And so that is what we do. What is the denominator? The denominator, because I want to be 1, I want this perpendicular height to be equal to 1. So that is what I do. Wherever my perpendicular height is coming out to be 1, it is that point that I choose to be my point on the terminal ray. So that this distance is 1 and thus I obtain my triangle of reference, which is OMP. Also, not just I choose the length of the perpendicular to be 1 so that I just get B in picture, I also take this B, which is the base, to be equal to the variable S. So what do? Here, in triangle of reference, of the angle theta, that is the triangle OMP, what do? We take the length of the perpendicular, which is PM, to be 1, and we take the base, which is OM, to be equal to S. And then again we have just one more side to be found out. How does that come? Just use the Pythagorean identity, which you know is that hypotenuse square is equal to base square, which is OM square, plus perpendicular, which is your PM square. And you get that your OP square is equal to your S square plus your 1 square. And therefore, OP turns out to be under root 1 plus S square. That is what you get as the length of the third side, which is under root 1 plus S square. Now, as you can see, you have obtained the lengths of all the three sides of the triangle of reference of theta. And now it is possible to find out every trigonometric ratio corresponding to this angle theta. Let's begin with getting what sine theta is. Now, sine theta is perpendicular upon the hypotenuse. What is the perpendicular? It is PM in the triangle and you have OP as your hypotenuse in the triangle. So, what is my PM turning out to be? My PM is nothing but 1. And what is my OP? My OP is under root 1 plus S square. But wait a minute. What is my S? Well, if I talk about this expression, I get that my cot theta is equal to B upon P, but the base has length S and the perpendicular has length 1, which implies that cot theta is S. Can you connect it with the previous conversion that we did? Over there, sine theta came out to be S, and that was deliberate effort to bring that particular ratio to come out to be equal to S. And this is what is the main strategy. Over here, because we wanted to express every trigonometric ratio in terms of cot, the aim became to bring cot come out to be equal to S. And for that, it was needed to make the P, which is the perpendicular, sitting at the denominator as 1 and B to be equal to S. And then we are going to sail through the entire process. Now that cot theta is S, our sine theta comes out to be 1 upon under root 1 plus cot square theta. This is the expression that you obtain of, or basically sine is expressed in terms of cot in this way. If I talk about cos, what is cos? Cos theta is base upon the hypotenuse. So what is your base? Base is nothing but OM and your hypotenuse is OP. Now your OM has length S and your OP has length under root 1 plus S square, and that is why your cos theta comes out to be cot theta upon under root 1 plus cot square theta. And this is how cos is expressed in terms of cot. Moving to the third ratio, which is tan. Tan theta is nothing but 1 upon cot. That's it. What do we need to do further? Nothing, because here I have expressed my tan in terms of cot. And so this is what is the expression of tan in terms of cot. Whereas if I move to expressing cosec theta in terms of cot, what will I have to do? Well, cosec theta is 1 upon sine theta. Reciprocal of sine, but 1 upon sine will make it under root 1 plus cot square theta upon 1, thereby giving you that cosec theta is under root 1 plus cot square theta. Similarly, if I wish to obtain sec theta, sec theta is nothing but the reciprocal of cos theta. So the reciprocal of cos theta, if you do, you reciprocate these two expressions and you get this to be equal to under root 1 plus cot squared theta upon cot theta. And the last one, which we literally do not need to find, is the cot theta, which already is in terms of cot theta. And here the rest of the 5 trigonometric functions we have expressed in terms of cot theta. This is how you need to do the conversion of every trigonometric ratio in terms of any trigonometric ratio. We'll just make a table which you will have to need to note down in your notebooks, and then you will have a thorough understanding and the collection of all the possible conversions.